University in New York. This is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the top stories in science and politics. Our lead story today is, well, it's now official. President Donald Trump has pulled the United States out of the Paris Accords, something that took years to create with almost 200 nations signing on to this historic agreement, but it's now official. And the question is, well, what does it mean? Where do we go from here? What's going to happen to the planet Earth? We'll say a few things about that. And then after that, we'll talk about outer space. We'll talk about NASA's latest space venture called the Solar Probe Plus. For the first time in history, we're going to send a space probe right through the atmosphere of the sun. Something that was once thought to be impossible or dangerous, we can now do it. And we're now beginning to explore perhaps the most important object in the solar system. That is the sun. And with that, the ability to understand the solar wind, which in turn can be a problem. By wiping out satellites, by injuring our astronauts, all of that will be studied by the Solar Probe Plus. Well, let's just jump right into some of the top stories of the past week. The big story, of course, flashed across the headlines is President Donald Trump has pulled the United States out of the Paris Accords. And it raises lots of questions. Is it the end of the world? Now, somebody may ask the question, what is it? I recall, I learned that the Senate has to ratify treaties. The President of the United States cannot unilaterally pull out or create a treaty. True, but it turns out that it's not really a treaty. It's not the Paris Treaty, it's the Paris Accords, because President Barack Obama sidestepped the United States Senate and used his executive privilege to create an accord, the Paris Accords. So what President Trump did was essentially reverse the earlier decision of President Barack Obama to sign on to the Paris Accords. Next question, well, what does it mean? Does it mean that President Barack Obama's work will be simply gone up in smoke immediately? And the answer is no, because of the fact it takes 3 years for many of the provisions to go into effect regarding the cancellation of the accords, meaning that by the time a new election comes around, at that point, the Paris Accords are going to be over. So in other words, nothing is really going to happen at the present time. And then the next question is, well, what does it mean for the future? Well, luckily, there's a tremendous amount of momentum already built in. There are lots of changes that have been made over the last decade in the economy, and they're not going to simply go away. So what's going to happen immediately? The answer is nothing. Things are going to be pretty much the same because of the fact it takes 3 years to implement leaving the accords. And second of all, there's been so much momentum built up over the last several years. However, let's be clear about this. Global warming is real. It's happening. And we see it everywhere. And so even though the United States will not be a leader in the effort to rein in global greenhouse gases, the movement will continue without the United States. Now, some people, of course, say that global warming is a hoax. We have these liberal, pointy-headed professors at different liberal colleges creating a storm of controversy over nothing, they say. And here are some of the arguments that they use. First of all, they say that there are natural cycles of warming, and that's what we are experiencing today. Well, in some sense, that is correct. That is, 10,000 years ago, we had the last ice age. So things have been heating up since the last 10,000 years. Obviously, with the ice melting as a consequence, the Earth has been heating up. But this is on a time scale of 10,000 years. However, recently, within the last 50 or so years, there's been a spike in temperatures that is not part of the warming cycle since the end of the last glaciation. And that's why scientists say, aha, perhaps it is human activity that's causing this recent spike. Now, I'll be very frank about this. I used to be a skeptic myself. I used to say, come on, give me a break. The Earth is so big, humans are so small. how can we puny humans possibly affect the atmosphere of the planet Earth? But then as time went by, I began to question some of my beliefs because, well, was it really a random fact that we have so many things happening simultaneously along with this spike in temperature? First of all, the glaciers are receding. If you have satellite photographs of all the major glaciers on the planet Earth and compare pictures taken 50 to 100 years ago, we see that all the major glaciers on the planet Earth are receding, and receding rapidly. Next, Greenland. If you ever visit Greenland, one of the astonishing things that come right to the fore is the fact that, well, Greenland is thawing out. Everywhere you go, you see the effects of the melting of the tundra, the heating of the temperatures on Greenland. Greenland is thawing out. And then if you visit the Arctic, it turns out there's been a 50% reduction in the thickness of Arctic ice in the last 50 years. That's right, 1% per year reduction in the thickness of Arctic ice. How do we know that? Because for the last 50 years, we have been visiting the North Pole. Ever since the Nautilus visited the poles, we've been able to calculate the thickness of the ice in the Arctic, and we find that, yes, definitely, there's been a 50% reduction. Now, this depends upon the seasons, but it turns out that in summertime, the North Polar ice disappears completely. It's seasonal, of course, but here we have a situation where this never happened in modern times. Next, if you take a look at temperature on average, the last year went down as the hottest year ever recorded in the history of science. In fact, we're on a roll. The last decade was the hottest decade ever recorded in the history of science. And if you graph it, you see there's a line going upwards, not downwards. Next, if you take a look at the South Pole, many climatologists thought that the South Pole was in fact quite stable, and we're not going to have to worry about any breakup of the ice until perhaps the next century. Well, all those predictions turned out to be wrong. It turns out that chunks of the South Pole are now breaking off. In fact, the largest ice shelf C is about the size of the state of Delaware. Can you imagine? The state of Delaware made out of ice breaking off from the South Pole. And realize that the South Pole, in turn, helps to determine the weather on the planet Earth. And we now are beginning to see the instability in the South Pole. Next, if you look at extremes of temperature, we see extremes taking place all the time as we now have 100-year forest fires, 100-year flooding, 100-year storms. In other words, global warming is really a misnomer. It's really a bad phrase. It should be called global swings, because we're not seeing the even rise in uniform temperature on the planet Earth. No, that's not what we're seeing. We're seeing violent swings, and that's what global warming really does. Because energy accumulates in the atmosphere, and energy sloshes around the planet Earth. That's why you'll have flooding in one area, a drought in another area, and you see different kinds of 100-year distortions take place in our lifetime. So we're not talking about 100-year events anymore. We're talking about events that take place every few years. And so the point is, all the arrows are pointing in the same direction. We're not seeing one arrow point in the other direction to counteract global warming. Well, the critics of this theory say, well, wait a minute. There is a satellite. There is a satellite there that shows that the Earth is actually cooling off, not heating up. Well, yes, there was a satellite like that, but it turns out it was miscalibrated. When scientists went more carefully and checked the calibration of this lone satellite going in the wrong direction, we found out that it was miscalibrated, and that's why it was giving us the wrong numbers. So now some of the skeptics are saying, well, yeah, okay, maybe the Earth is warming up, but it's not caused by human activity. It's caused by natural cycles, or who knows, maybe the sun is heating up, but it's not man-made. Well, this is where computer simulations come in. Computer simulations are not 100% perfect, but they're a lot better than simply licking your finger and putting it in the wind to find out what the weather is going to be like. And the computer programs all pretty much agree with each other. Now, back in the old days when these studies were first being done, you could, quote, run the videotape backwards. That is, take this computer program, simply reverse the direction of time, which is easy to do on a computer program, and see whether or not you can reconstruct the past. Well, back then, these programs were kind of crude, and they had a hard time predicting the past. That's why some people would say, bah, humbug. These computer programs are only as good as the nonsense you put into them. Well, that was years ago. Now, when we run the videotape backwards, we can actually predict the past. And that means we are reasonably confident that our computer programs are telling us the truth. And they are converging, not just computer programs that are all over the place randomly predicting things, but yeah, it turns out these computer programs are converging now as to what the future is going to look like. And these computer programs show that with 95% confidence, not 100%, but with 95% confidence, it means that, yes, it is human activity, not natural cycles, that are heating up the planet Earth. Well, what are we going to do about it? Well, the nations of the Earth realize that if they gang together, they can actually begin to make treaties that have an effect on the planet Earth. For example, the Montreal Protocols. Years ago, it was noticed that there was an ozone hole over the poles on the planet Earth, caused by the introduction of gases like freon, chlorofluorocarbons, which are used in refrigerators. Now, everyone, of course, loves our refrigerator, especially when it's at peak summer. But we found out that, yeah, freon gas and chlorofluorocarbons can go into the atmosphere and disturb the ozone layer. The ozone layer protects life on the Earth. The Earth is bathed by X-rays and dangerous radiation from the sun, which can cause cancer. But for the most part, it's absorbed by ozone, which is O3 minus. However, with the introduction of freon gas, a hole began to form over the North Pole and the South Pole that was linked to chlorofluorocarbons. So the Montreal Protocols were passed, and it made a difference. It really made a difference. You can see that the hole, well, yeah, it's still there, but it's not growing so rapidly, and parts of it are being reversed. And so nations of the world were emboldened to go to the next step beyond the ozone layer, and that is global warming. And so they passed the Kyoto Protocols. Well, the Kyoto Protocols have now been replaced by the Paris Protocols, and that's where we are today. It turns out that in 2015, many nations of the Earth could hammer out a compromise statement, and nations began to sign on in 2015. And by 2017, we have 147 parties that have ratified the Paris Agreement, of which 195 have signed it. However, there are two holdouts. The two major holdouts are Nicaragua and Syria. And what are the goals of the Paris Protocols? The goal is to make sure that temperatures do not rise beyond 2 degrees centigrade above what they were during the industrial times. Now, it turns out that China and the U.S. have the largest economies, and these economies, in turn, are linked to the creation of carbon dioxide because, of course, we have coal plants and oil refineries, and we have car emissions. So China and the United States together account for about 40% of the world's carbon emissions. Now, under President Barack Obama, he committed the United States to reduce carbon dioxide emissions by 26 to 28% by 2025. So that was a goal not mandated by the Paris Agreement, but the Paris Agreement allowed nations to set their own goals, and President Barack Obama committed the United States to reduce carbon dioxide by 26 to 28% by the year 2025. However, if, for example, the United States were to pull out of the Paris Agreement, that could add an additional 3 billion tons of carbon dioxide into the atmosphere. Also, the Solar Probe Plus is making headlines. That's a NASA probe. In fact, it's historic because it'll be the first probe to go right through, skimming through the atmosphere of the sun. It's scheduled to be launched next year in 2018. It'll have a 6-year mission to probe within 4 million miles of the surface of the sun. Now, why is that so important? Well, first of all, it's rather embarrassing that 50 years into the space age, we've sent space probes to Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, even Pluto. We have visited comets. We have visited asteroids with our space probes, but we have not yet visited the sun, which, of course, is the most important object in the entire solar system. Now, of course, all of us can marvel when our space probes go whizzing past the rings of Saturn, but let's face it, the rings of Saturn don't affect us in any way whatsoever. However, the sun affects us every single day. First of all, one of the things that the Solar Probe Plus is going to investigate is the solar wind. Now, the sun has a solar wind which bathes the Earth in radiation, and we see the effects of that with the northern lights and the southern lights. That's when radiation from the solar wind comes funneling down the North Pole and the South Pole, following the lines of magnetism. When it hits the atmosphere, it causes ionization of the atmosphere and that characteristic glow that we marvel at when we look at the northern lights or the southern lights. Well, that's normal. However, sometimes the sun has a temper tantrum. Sometimes it throws off solar flares, even coronal mass ejections, and then, well, you guessed it, all hell can break loose. First of all, we can have blackouts. In fact, it turns out that in Canada, Quebec was hit very hard with a solar flare from the sun, knocking out power lines. Second of all, satellites can be damaged. That's right. Satellites have been known to be fried by the solar wind when it gets out of control, meaning that telecommunications, the internet, weather satellites, yes, they could be knocked out with a solar flare. This means that the astronauts in the space station have to be extra careful. They have to monitor the space weather. That's right, the space weather. They have to monitor the solar wind. Because if a coronal mass ejection hits the space station, the astronauts have to very rapidly go to a special compartment of the space station where they have a certain amount of reinforcement and shielding against radiation. So astronauts definitely have to be worried about the solar wind. Not to mention the fact that our brave astronauts who go to Mars are going to have to withstand numerous bombardments by the solar wind. In fact, if you think about it, we humans have never ventured beyond the Earth-Moon orbits. We've never gone into deep space like our space probes, where there's a lot of radiation, meaning that the solar wind is going to be a top priority for our astronauts as they go to Mars. Now, the next question is, what about a maximum scenario? What about the worst-case scenario if we have a gigantic solar flare that flings huge amounts of plasma radiation in the form of a coronal mass ejection and it hits the Earth? What could happen? Well, all hell could break loose. Back in 1859, we had the Carrington event. Carrington was an astronomer who was observing the sun, and he noticed that the sun was going berserk. A gigantic solar flare coming out of the sun. Well, it turns out that minutes later, yes, some of that radiation was hitting the Earth, and boy, did it cause trouble. First of all, back in 1859, we didn't have much electronics except for telegraph wires. It turns out that some of the telegraph wires blew out. In fact, some of them were energized by the solar wind, and as a consequence, the telegraph wires sprung into life all by themselves. Now, we physicists today know how much radiation it would take for the telegraph wires of 1859 to be suddenly energized, and the results are astounding. In fact, the American Physical Society and other organizations of physicists have analyzed what could happen in a maximum scenario if a coronal mass ejection hits the Earth directly. Property damage, $2 trillion. That's trillion with a T, not billion with a B. This means power blackouts of power stations, It means short circuits. It means that rescue crews from other cities cannot come to rescue us because they too have been affected. In other words, thousands of electrical appliances will be wiped out in the northern and southern hemispheres in case of this event. This means that, for example, commerce comes to a halt, credit card transactions cannot be done, the internet goes down as a consequence of this. This also means that society as a whole will be thrown back about 100 years into the past before the coming of the electric age. This means that on the planet Earth, we would have an electromagnetic pulse that would fry most electronics on the Earth, meaning that businesses would come to a halt. In fact, several years ago, we had a power blackout, an artificial man-made power blackout, I should point out, not a natural one. And, well, I was near Times Square when it happened, and it was a mess in Times Square. Tourists could not check into their hotels. Credit card transactions could not take place. All commerce basically came to a halt, and the tourists had to basically stay in the lobby of the hotels until the credit card machines could be re-energized. Now, that's Times Square. Can you imagine what's going to happen elsewhere on the planet Earth? Mass starvation could begin. Because let's say there's a run on the supermarkets as a consequence of all the panic, and let's say as a consequence refrigerators go out, meaning that your food will start to rot in about 2-3 days, meaning that you're going to have to throw out all the rotting food in your refrigerator. And when you go to the supermarkets, well, there's no food in the supermarkets. There are no rescue crews from other cities because they too have been wiped out. And sooner or later, you're going to have food riots because people are going to be starving. They're not going to have any food at the home. They're not going to have food at the supermarket. There's no food coming in from the outside. And that's just one of the many inconveniences that could take place if we have another Carrington event. Well, you may say to yourself, we got to do something about it, right? Well, we physicists went to Congress. We went to Congress and petitioned Congress to donate a pittance, pocket change in the millions of dollars to take preventive measures, such as shielding around our power plants, shielding around our satellites. Also redundancy, so that if one power station goes out, we have another power station or backups ready to go. And that way, it would minimize the danger of a major Carrington event hitting the United States. Well, what was the reaction of the United States Congress? Many congressmen went through what is called the giggle factor. That is, their eyes rolled up to the heavens and they began to giggle. I mean, a threat from outer space? This is not Hollywood. This is the United States Congress, they said. And as a consequence, we physicists got no response whatsoever from the United States Congress. No money to build a backup system. No money for shielding. This is just common sense. And yet we couldn't even get common sense to come out of the United States Congress. So the point is that Carrington events do happen. In fact, in 2012, we almost had one. Now that we're on to the danger of things like Carrington events and electromagnetic pulses, we physicists are tuned into the sun with our telescopes and our sensors, and we found out, sure enough, in 2012, we dodged the bullet. We almost had a direct hit. Now, let me explain. Every 11 years, we have the sunspot cycle, and we now realize that many of these solar mass ejections come out of sunspots. So a sunspot, in some sense, is like a cannon. It's a cannon that shoots gigantic balls of plasma into outer space, one of which hit the Earth in 1859. Now, of course, these events have been taking place since time immemorial. Since even before the beginning of Homo sapiens, the sun has been shooting from the sunspots gigantic balls of plasma into outer space. But back then, we had no electricity. Back then, we were not in the electric age. Now we are. We are fully dependent upon the space program and electronics. And as a consequence, when one of these coronal mass ejections coming out of a sunspot is shot into the sky, hits the planet Earth, it could cause havoc. Now, how often do these things take place? We now realize that these things take place all the time, but they miss the Earth, and that's the key. There's a lot of space out there, but it turns out that coronal mass ejections take place all the time, and they peak every 11 years during the sunspot cycle. But for the most part, they miss us. So in other words, we're like the sitting ducks in a shooting gallery. For the most part, the guns in the shooting gallery shoot all over the place and miss us. But once in a while, they hit. In fact, in 2012, as I mentioned, we had a near miss. Now, how often do they hit the Earth? We don't know for sure, so we went into ice cores. That is ice from the Arctic, drilled into the ice, and started to extract layers of ice that were ionized centuries ago because of a coronal mass ejection. And we were rather surprised. First of all, in the last 150 years, since 1859, there have been no major Carrington events. But going beyond that, it turns out that every few centuries, we have another Carrington event. How often? Well, we don't know for sure, but every 200, 300 years. In other words, it could happen tomorrow. It almost happened in 2012, or we may have to wait for centuries for the next direct hit to hit the planet Earth. So what's the moral of the story? The moral of the story here is A, we scientists are beginning to realize that the sun is not as predictable as we once thought. When the sun has a temper tantrum, it can wipe out satellites, endanger astronauts, but when the sun goes berserk, we're talking about throwing civilization as we know it 100 years into the past. And last, how often do we have such Carrington events? And the answer is, well, we don't know. Perhaps once every few hundred years. However, they could also happen tomorrow because we're in the middle of a cosmic shooting gallery. It's random chance whether or not one of these sunspots is aligned directly at the planet Earth, and we are right in the crosshairs of a coronal mass ejection. At that point, all bets are off. Well, I'm afraid that's it for the first part of Exploration. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. Stay tuned now for the second half of Exploration when we bring on Professor Peter Ward. What happens if the greenhouse effect goes out of control? What happens if the ice caps begin to melt? What happens if we have a flooded Earth? And so we're going to bring on Professor Peter Ward, author of the book, Flooded Earth, to talk about the consequences of what happens if we do nothing. In other words, if there's no Paris Accord, in other words, if we simply let the greenhouse effect run amok, what's going to happen to our livelihood as sea levels begin to rise, as monster storms begin to flood our cities? Just remember that about 50% of the population of the United States lives next to the ocean. And now I'd like to introduce our special guest for today. He's Professor Peter Ward. He's a professor of biology and earth and space science at the University of Washington in Seattle. The book is rather disturbing and is hitting the bookshelves this week. The book is called The Flooded Earth. The book is controversial. However, it gives you a frame of reference as to what scientists are thinking if sea levels continue to rise, not 1 foot, 2 foot, but 5, 6, 7, 8 feet above normal. What happens to our great cities? Professor Ward, you're a professor of biology and earth and space science at the University of Washington in Seattle. However, as a youth, what steered you in the direction of science?
Well, thanks so much for having me. And I think scientists know from an early age that they're going to be scientists, so it was indeed youth. What got me going were dinosaurs. My mother and father were from New York. I grew up in Seattle. We didn't have a single dinosaur skeleton, and so I was given this guilt treatment that I had to be in Seattle, and it's my fault or something that there were no dinosaur skeletons. But that got me going.
Okay, and that set you off. And how did you get interested in astronomy and earth and space science?
Well, I certainly started in paleontology, so I was looking at my feet all the time down at the ground. But it became evident, I think, in the first part of this century, or really the end of the 20th century, that there was a great deal to learn about life in space and especially how other Earth could be constructed from what we knew in our own Earth history. And so deep Earth history can inform us about astrobiology. And in the book I've just done now, it is deep Earth history which can inform us about what climate change is capable of.
Okay, well, the book is called The Flooded Earth, Our Future in a World Without Ice Caps. So let's start with the ice caps. The North Polar region, over the past 50 years, since submarines have visited the North Pole, seems to have decreased by 50% just in the last 50 years. So what is your projection of the North Pole and also Greenland going into the future?
Well, the great dream of the Europeans coming to North America was for the Northwest Passage. I mean, this was a driving impulse to try to find a quick trade route to China. We're going to have that. But what I really didn't understand thoroughly enough was the difference between an ice cap and an ice sheet. All of the North Polar ice cap can melt away, and it will have no effect, essentially, on sea level. It is the ice on land, the ice sheets, which are the biggest of which, of course, are Greenland and in Antarctica. Anything that melts on those goes directly into the ocean and raises the level of it. And the biggest, scariest scenario is equivalent to what we call an ice sheet collapse. So imagine you have a cup of really warm water and then dump in about 10 or 15 ice cubes, and up goes the level of that water really fast. Well, that is the scenario for an ice sheet collapse in Antarctica.
Okay, well, we've heard about what's happening in the North Polar region, but in the South Pole, we have huge chunks of ice breaking off. But what does that mean, given the fact that most of the South Pole seems stable, at least temporarily?
You know, I've come back from two separate trips to Antarctica over the last 2 years, and we're looking at deep time events of the climate down there, but you can't help but notice what's going on all around you. It was melting like crazy. When you have both kinds of ice down there, you've got floating ice, which, again, if that melts, doesn't matter. But you've also got all this ice on land. When it melts, the water goes down to the ice rock contact, of course, and that acts as a lubricant. So when you have really anomalous warming, stuff that is on the edge of this can calve off into the ocean. That causes great global change in terms of sea level rise.
Okay, and talking about sea level rise, doesn't the heating of the Earth itself cause expansion of warm water, which causes the sea level to rise? Just the sheer fact that the Earth is warming up.
It sure does. And matter of fact, if we stopped all emissions right now, we just went completely emission neutral, the ocean is still going to rise in its level because of thermal expansion. There's been so much warming already that the ocean has a lag effect, but over the next 40, 50 years, we could expect nearly a 3-foot sea level rise if, based on the temperatures that we have now and the continued warming, just from the thermal expansion, no ice at all.
Okay, 3-foot rise without any ice, and I guess for every 1 foot vertical that you lose, how much horizontal seacoast do you lose?
Well, the seacoast itself is affected more strongly by storm surge. And you can think of storm surge as equivalent to going off a diving board. You jump off a diving board at a given height, but if you bounce a couple of times, you go way higher. It's as if you have a launching platform as sea level rises. The storm surge, which are the nasty big waves that rise higher than normal sea level, can hit coasts. But the sideways movement of the ocean is far more serious in terms of what its salt does. Salt goes laterally quite easily, and depending on the type of soil, it is the salinization of the sea level crops that I think is the greatest single danger from sea level rise. It's stunning how much of the world's productivity, and especially the rice regions in Southeast Asia, are on deltas. A delta is built out from a river hitting a calm ocean. If you have a 3-foot sea level rise, every delta on this planet will disappear. We're talking about the Nile, the Brahmaputra, the Mekong, and these are all enormously productive areas. So this is the big blow that is coming The equation is we're going to have a rise in sea level at the same time we have a rise in human population. As you know, we're at 6.6 billion now, but we're heading towards 9 billion. And this, too, is built into the system. It's kind of like the warmth of the ocean. We could do tremendous birth control efforts now, but we're probably still going to hit that 9 billion. So the intersection of 9 billion with reduced agricultural yields because of the sea level rise is the scariest aspect.
Okay, well, let's assume that we do nothing. That is, we simply treat everything as normal. We keep on spewing carbon dioxide into the atmosphere. Let's take the world 2050. In 2050, what will coastal cities like Boston, New York, Miami, Los Angeles, San Francisco, Seattle, what will they look like if we just keep spewing carbon dioxide in the air as if there was nothing wrong, and we project 50 years into the future?
Well, 2050 is still not going to be apparent that we're in a crisis. It's kind of like watching a speed car as it leaves the Indy 500. If you catch it in the first 10 feet or so, it's not going very fast. But acceleration is an interesting thing. It will be apparent to all city planners in 2050 that something new is going on, and they won't like it. Much of city infrastructure is now buried. People put down, obviously, all the sewage, but now so much of the electrical and advanced communication systems are underground. They were not engineered for salt water. They were engineered for fresh water. Bringing a lot of salt into city infrastructure is going to be a huge headache. It's also going to be a headache for trying to keep freshwater reservoirs going and freshwater aquifers. So 2050 is the time when the alarm bells are going to be ringing. The populace isn't going to see much. It might only be a foot rise by then, but certainly there will be urban red lights going off like crazy.
Well, in New York City, a few years ago, we had a gigantic nor'easter which sent a surge of water into Manhattan, which flooded the subway system. And it was not even a very big storm that did that. And some people think that storm surges, even before sea level rise goes to catastrophic levels, storm surges could paralyze the electrical, the plumbing system, and the infrastructure of a city. What are your thoughts?
Yeah, storm surge is definitely the most dangerous short-term effect of this. Look, we saw what storm surge did to New Orleans. It wasn't so much the hurricane itself, Katrina, that battered New Orleans. It was the storm surge. And once again, your storm surge comes from a mean sea level. When you keep raising that mean sea level, storm surge goes up, way up, higher. The most endangered creatures are therefore freshwater plants. And what I'm really breaking my heart is trying to think what's going to happen to the Everglades. You've got this enormous freshwater biosystem, which will be so threatened by both storm surge and simply rise in sea level. You cannot live in salt water if you're a freshwater plant. And unfortunately, no saltwater plant, like a mangrove, makes food that humans can eat.
Something to think about. Now let's turn the wheels of time to 2100. What will the great cities of the world look like in 2100?
Well, 2100, there will be 3 feet, only 3 feet if we're lucky, and 5 to 6 feet if we're not lucky. And by lucky, I mean we turn off the lights right now. If it is business as usual, and I suspect it might be because of the increased population numbers, there will be that 3 to 5 foot. The most hard hit will be the wharves. Global transport by ship is still the main means of moving great amounts of food around. CNN projected when I was in Antarctica a few months ago that even a 1 foot rise in sea level will cause shipping terminals and ports and docks and dock heights to have to be modified. And their projection was $1 trillion or more by about 2040 just to spend on the docks. Now, San Francisco Airport, I've landed on that airport over and over and over. A 3 to 5 foot sea level rise in the Bay Area will remove that airport entirely. And so just from the economic points of view, that 3 to 5 foot sea level is going to cause such an enormous financial burden on coast cities.
Okay, the big question. Will cities have to be abandoned if sea levels continue to rise 3 to 5 feet? And which cities are we talking about?
Well, we've done a lot of projections on this, and I've been talking to some Dutch engineers. The consensus, and again, this is really just consensus of people looking forward, is that civilization and the cities now could probably absorb a 3-foot, 4-foot, even at the worst case scenario, a 5-foot sea level rise and survive. But anything above 5 to 6 feet for a lot of cities is not survivable. New York has high ground. It can simply move back, but Miami cannot. Miami is I think, the poster child of the type of city that will disappear, as Galveston, Texas will, much of the South Florida cities will, and the Netherlands, of course, is in huge trouble. They already have a significant, I think it's 30% of the land area is already under sea level, and they spend an appreciable amount of their GNP on dikes every year. Dikes and the equivalent of dikes, sometimes big sandbars. When the global economy gets hit hard, it affects everybody, and I think that's what's coming.
Well, what about Boston? Large parts of Boston were reclaimed since the Revolutionary War. If you look at old maps of Boston, large parts of Boston didn't exist until recently. So what's going to happen to Boston?
Yeah, all reclaimed parts of cities are going to go away. The same with my city of Seattle. Our entire bay, Elliott Bay it's called, there's an island. Our major shipping port is an island built up from reclaimed sediment, just as Boston is. And once again, the 3-foot sea level rise allows storm surge, the big storms, to come whipping in and remove a lot of that sediment. You're not going to be able to hold that together. So any city with reclaimed sediment construction, and lots of the airports in Asia, and especially in Japan, they've been building airports out on the water. China's just done it too. All those things will have to be rebuilt somewhere else.
And what about San Francisco, Los Angeles, and especially what's going to happen to New Orleans, where large parts of the city are actually under sea level?
I think New Orleans will have to be abandoned ultimately. It might be a century or two. San Francisco is very interesting. They're very progressive engineers down there, and believe it or not, they have a plan for building a dam right under the Golden Gate Bridge that would save every one of the Bay cities. You could hold off sea level rise by building this dam. Otherwise, it's going to be a whole series of smaller dikes and systems and try to save what you can and lose what otherwise. Los Angeles is in an interesting position, too, because the city itself has obviously a lot of high ground, but there are very low-lying areas in Los Angeles that, again, will be inundated to the point that some huge storm comes, salt water is pushed way inland through storm surge, killing off the plants that are there. And then what do you do when you're living in a house that is flooded out by not fresh water, salt water? A saltwater flooding event is way worse than a freshwater flooding event.
And what about London, where we have gigantic underwater devices to help control the water of the Thames River? Are we all going to be like that? Are we all going to be like the little Dutch boy putting our finger in gigantic dikes that we're going to build around our cities? What are we going to do about this?
Well, the British have thought a lot about sea level rise, too, and they are planning on contingencies for up to 5 feet. And you just really hit it. They're thinking about what sort of engineering do we have to do to save our cities. Historic cities, such as London and any of the cities in the Mediterranean, will do everything and anything to try to keep their shorelines as they are now. But it really all depends on where we can stop this. Look, if we melt every single glacier on the planet, we have a sea level rise of over 200 feet. That was the case less than 17,000 years ago. We know from the deep past that when carbon dioxide has been 1,000 parts per million, there is no ice sheet. And we're at 380, 390 and climbing. It's just, that to me is the spookiest aspect of it all.
Okay, and what's going to happen to growing areas of the world, like California has the San Joaquin Valley, other places have gigantic growing areas. What happens when salt water begins to intrude upon these growing areas?
Agriculture becomes very dicey. Obviously, the San Joaquin Valley is enormously threatened. 20 years ago, it was already recognized that there's salt creeping in. Once again, if sea level goes up a little, salt goes sideways a whole lot. And any sort of salt within your soil reduces productivity and ends to the point that you can no longer grow crop plants. So this San Joaquin Valley itself is endangered. The northern Sacramento Valley is in trouble. And as I mentioned earlier, every delta on the planet and all that rice from Southeast Asia, those are the targeted places that we should worry about most agriculturally.
Okay, and well, let's be very specific. I live in Manhattan. Manhattan is a little bit above sea level. The place where I am is about, 15, 20 feet above sea level. However, certain parts of Manhattan are very close to sea level. Wall Street, for example. So what is Manhattan going to look like, and are we going to have to use a system of dikes to prevent the flooding of Manhattan?
Yeah, there will have to be some sort of mitigation going on in Manhattan, if not for the sea level rise itself, certainly for the storm surge. Again, a small level storm surge is the takeoff point for, a small level of sea level rise is the takeoff point for storm surge. And in my book, I actually did some elevation counts for various areas and various streets in New York. And not off the top of my head, I actually projected winners and losers in New York City and its boroughs.
Okay, and let's talk about Venice. Engineers have seriously looked at the problem of Venice. San Marco Plaza, the famous plaza, is actually underwater for parts of the year. So what have we learned by trying to do these gigantic engineering projects like for Venice?
Well, Venice is really interesting because they're putting out into the bay that Venice faces what is sort of a non-traditional dike in a way. It's not like a single wall that the little Dutch boy can put his finger in. But what is interesting and sort of alarming for Venice is also in Holland. It's not just the sea level rise, but it's the fact that the rivers behind yourself. These big cities were often built upon rivers. And because we've got global warming, it's not snowing in many of the mountains. In the Alps and in the Sierra, for instance, snow level is higher. And so instead of snowing in the winter, it rains. And these rivers rise at times they never used to rise before. So Venice is fighting a two-front war, as is many of the Dutch cities. You have to worry about the river that runs through you as much as the sea coming at you. And as any of the military geniuses said, two-front wars are often hard to win.
So Venice may have to be abandoned at some point, you figure?
I would suspect, yes.
Okay, and your book goes beyond 2100, goes to 2300 and beyond. So what is the coastline of the world going to look like now beyond 2100? If I have a map of the world, what will school children see? The North Pole gone, the coastline changing. What will the Earth look like beyond 2100?
Well, it really boils down to some simple geology. Continents, as we know, move around. In the direction that they move, like North America's west coast, there are high mountains generally. But trailing edges, we call them passive edges, don't have mountains, or they have mountains that eroded away, as our east coast does. So you've got the enormous Gulf Plain, you've got the enormous East Coast Plain in front of the Appalachians. There'll be inroads all through that. The problem that we see is that most estimates and models think up to 2100 and stop. But at 2100, if it's business as usual, say we kept it at 3 feet, it doesn't stop there. It keeps going in accelerated fashion. So if you have 3 to 5 feet by 2100, it's not going to mean that you would have twice that by 2200. You could have 3 times that high. The acceleration is the most ominous aspect of this business.
So let's just do a computer program. Assume that at some point we stop greenhouse gases into the future, but we just let the computer program run. What will the world look like? Will all the great cities be underwater by then, by 2200, 2300?
No, ice sheets in Antarctica, they are thinning, and they're thinning in both Greenland and Antarctica. A great deal of that water is going in, but the ice sheets are enormously thick in both places. Greenland is far more endangered than Antarctica is. You're not going to see wholesale flooding of the cities by 2200 or even 2300, which possibly gives us time, but you're certainly going to see effects where the cities that will have to be abandoned, I think that will already be taking place. We just have to maintain these ice sheets with as much integrity as we can, and that means slowing the global warming temperatures, which seem to be inexorable. Look, we just went through this huge recession. We should have had 2 or 3 years because of the economic downturn when emissions could have been or should have been reduced. They weren't. I mean, they're right up at the IPCC's maximum emission predictions. We're not lowering emissions. We're increasing emissions.
Okay, now let's go into the past. You can do that because we can drill into the ice cap and get ice cores from thousands of years ago. 10,000 years ago, we had the Ice Age. It was very cold 10,000 years and beyond that. So how far back in time do you have to go to find a time similar to what we're going to be experiencing in the future? And what did the world look like at that time?
Well, the conventional answer is that if we get up to 1,000 parts per million, which would happen in 2 centuries from now, if we have some sort of control on emissions, a lot of us think that 1,000 parts per million would be a lot sooner than that. But you're going all the way back to a time called the Eocene. And the Eocene was a very interesting time when we had crocodiles up on the North Pole. We had palm trees in Seattle. We just had this wonderfully tropical climate. The bad news is that sea level was 240 feet higher than it is now because there was no ice. There were no ice sheets at all on the planet.
And when was that?
This was about 50 million years ago, but we only have to go back 110,000 years ago to see a world where sea level was at least 10 feet higher than now. And there's great evidence of this in Florida. In the Florida Keys, there's a beautiful quarry in Windley Key. It's a national park. And you can see big coral heads sitting 4 or 5 feet above sea level. Now, if you go offshore with your mask and flippers, you find the same corals, big Montastria they're called, living down about 10 feet deep. That's the shallowest they can live. So here is evidence, and we can date these with radiometric dating, that 105, 110,000 years ago, sea level was 10 feet higher than it is now, and the entire geography of that place was different. What caused that short-term rise, and this was a blip in the Ice Age, was orbital changes. But at the same time, we had a slight increase in carbon dioxide, and these two conspired to cause a great melt, enough to produce a 10-foot rise in sea level.
And that concludes our interview with Peter Ward, author of a disturbing new book called The Flooded Earth.